Okay, now I'm actually driving current. I put 8 ohms, two 4 ohms in series with the top of the MOSFET, and you can see we're pulsing at a 50% duty cycle. That's about half an amp, because it averages out 0 and 1, 5.5. And here's the schematic, and the Arduino's here, and it's driving it. So now we're going to see how fast we can drive it. I got it up pretty high before. I'm kind of being lazy, I'll admit it, and I'm just using delays instead of while statements to do my delays. But later on, I could design some sort of code with a tunable duty cycle with while time frames. Whiles are always better than silly delays, but these are microsecond delays. So let's see if it can actually go up to microsecond time frames. All right, so this should be 2 milliseconds for a period. All right. That looks like 2 milliseconds. Yeah, so 1, 2. Oh yeah, I should explain this. So the top signal is the driver on the gate of the MOSFET, and the bottom signal is the actual resistance over the load, which is indicative of the current going through the load. So, okay, let's try 0.1 microseconds, which I think is 10,000 hertz. Ooh, oh, we're starting to get some drift. So now you're starting to see that there's some ringing going on up here on the gate, and I'm only driving it at 9 volts, and then we're having it's taking some time to turn on there, but we're still pulling the whole 1 amp. This is like 0 amps, 1 amp, or vice versa. Let's try to go to 10 microseconds. So this would give us a 20 microsecond frequency. Ooh. Yeah, this is delays. The delay is imperfect, so there's going to be some little time wasted on the edges there. But yeah, it's starting to fall apart, but we're still getting some current pulsed at the end there. You see the average current going down, but that's still really impressive. Never driven a MOSFET before like that. I mean, I did in one other video, but I used a signal generator. Not fair. Using Arduino, now I have true control over stuff. But you can see the driver up here. So what is that? That's 1, 2, 3, 4, 5. So 5 blocks. Each block is 5. So 25 microseconds. So what's 1 over 25? Okay, so that's 40 kilohertz, which is pretty good. Pretty good. Don't know if we can go any faster. Let's try 80. Ooh, it's trying. But now you're starting to see that it's not totally being able to turn on the MOSFET. I guess this is the thing. This is the thing MOSFETs do when they turn on. As you move through the conduction, the triode, off triode, and conduction, you're seeing some sort of. Is that 1, 2, 3? So now it's 15. That's like 60 kilohertz. Pretty cool though. Pretty cool. Yeah, I'm starting to lose. And I mean, I would even put a pull down resistor on this system, you know, if I put a pull down resistor on here, or fix something up, and the important part is turning it off. So I think that's good, or might be turning it on. So very cool, very cool. And again, so everyone can see the parts I'm using. This is not a 460. This is a 260. Wrong keyboard. So, and this, I'm using an 8050 BJT. But yeah, everything in here is pretty accurate. And there's about 1 amp. Here, I'll slow the frequency back down and you can see. Well, look at me. I changed the part of the code that denotes what pin to write to, thinking that was the frequency. See, now we're switching. So we're on at 1 amp, and then we're off. And we're on. These are probably pretty warm. Woo! Yeah, 10 watts is actually a lot. So, yeah, that was switching 10 watts, but I could probably do more.